So, how do we go about measuring air pressure? Do we measure pressure by the number of particles in a box? Well, not exactly. I will say that when you're in an airplane, the altimeter in an airplane works very much like this box. It literally measures how many particles are in the air, and it translates that into an altitude. So if you're on the ground and you're at sea level, it measures the amount of these particles would be so tightly packed that in your airplane, your little quote box would measure that. As you fly higher through the atmosphere, it measures that there's less particles in the box, and hence moves a dial that shows you how what your altitude is. Now, back in the 1700s, how they figured this out was very unique. They had an experiment. Now, back in the day, 1700s, mercury, the element mercury, was really new. And it was almost magical because mercury is a very heavy metal. Now, let's just imagine I have this bucket filled with mercury. Now, number one, don't ever fill a bucket with mercury because you probably won't last very long. In fact, people back in the 1700s would take that mercury, they would dip a cloth in it and polish their hats, and it would make their hats real nice and shiny. And then they would put that hat on their head, and they would find that they got a little weird. They'd just act a little bit weird. And they called those people the Mad Hatter. You might have heard the Mad Hatter before. It's because they would take this mercury and it would make their top hats all shiny. Well, the other magical thing about not just making hats shiny, but the other magical thing about mercury is that because it's really heavy, this hammer would actually float on top of the mercury. So that's why people thought this was kind of an amazing substance, because you could take something as heavy as a hammer and you put it on this liquid and you would think it would just sink. Well, it actually floats because it's the metal here is less dense than the iron on the hammer is less dense than the mercury. So they thought that was unique in itself. So scientists back in the day were doing all sorts of experiments with this stuff. Now, they soon realized that it's dangerous for you, but before they really knew it was dangerous, they were doing all kinds of experiments because it was just such a unique thing. So one day, there was a scientist who filled a bucket with mercury, and he had a really large test tube. So imagine like a regular test tube, and on one end it's an open end, and you can pour stuff in and so on. Well, imagine they took that and they put it upside down here. Okay, so now the closed end is up here and the open end is sitting in the mercury. And one of the things that they noticed is that when they did that, the mercury actually would go up the tube. So the mercury would actually, where the level would be right here, once it went up in the tube, you could see it would go to a certain height. And they thought, well, that's pretty cool. Well, the next day they would come in and check on this, and they found that the height of the mercury would actually vary. So sometimes the mercury would be higher, sometimes the mercury would be lower. And they were trying to figure out what's going on. Well, one of the things that they figured out is that there must be something that's applying a pressure to this mercury. So if I take this mercury and imagine if I were to apply a pressure on this by hammering it, okay, if I hypothetically hammer without spilling or anything like that, but if I apply a pressure, a force, you can imagine that the level of mercury, if I apply a force, that mercury is going to go up. And as I unleash that force, it would go down. So higher the force, the higher the level of mercury. And the less force, so you can imagine if I were just to do a small one, okay, there's that. Now, if I was to do it really high, really hard, that pressure would go up. And then if I had less pressure, it would go down, and so on. They watched that mercury go up and down, and they were kind of wondering, why is this doing this? Well, one of the things that they figured out is that it's these very particles right here that are pushing down. All these particles have weight, and gravity is actually pushing all these particles down, and it's creating a force, and that force is what we feel is atmospheric pressure. Now, there are times if you look up to this, you can see how high some of these particles go. Now, if you go over here, it's not quite as high, but the particles are still pushing down. So on days where the atmosphere was really high, that would mean there's a lot of weight on this, which means there's a lot of weight on the mercury, which means that the mercury would go higher. Now, what we call this device is a barometer. This was the first barometer. A standard regular day, on the average day, if you take all the average pressure of all the days, that mercury would be at 29.92 inches. Now, on a really high pressure day where the atmosphere is really, really high up, that will go into the 30s, mid 30s for pressure. Now, on days where the atmosphere is not so high, where you can see right here, there's less particles pushing down, which means that there would be less pressure, which means that the mercury level would be lower, like in the 28. What they found out real quickly is that this barometer literally measured the amount of particles that are pushing down on this. Now, this is a helium balloon, okay? Now, as this helium balloon, we'll launch this thing up, you can see as it goes higher and higher, there's less particles in the air. Let's look at the balloon itself, okay? There's less particles up in the air, which means the space between the particles is a vacuum. Now, nature always wants to fill a vacuum. So what happens, all the particles inside this balloon want to try and fill in the spaces in here. So what do you imagine the balloon's going to do? As the balloon goes up in the atmosphere, the helium inside the balloon wants to try and fill in these blanks. So as it goes up, the balloon actually gets bigger and bigger as it goes up until eventually it pops. Now, there is a guy that actually did go in a little gondola like this in a balloon just like this. He took off and he went up and he got to way deep in the stratosphere, 126,000 feet. And what he did is when he was way up there, he opened up the hatch and he just jumped right out and parachuted back down to the ground.
It's still climbing and we'll start moving here in a little bit. Let's get a little bit. Release.
If you're scared, walk away, 'cause there's no need to feel ashamed. Yeah, we all feel the same. Where's your passion? Where's your fire
today? All right, now the whole road is looking now. I'm going over.
Jumper away. Speed 725. Showing Felix in a stable descent.
He wasn't hitting hardly any of those particles, so he was able to keep speeding up and speeding up and speeding up. It turns out he was moving faster than the speed of sound. Gravity was pushing him down, and he broke, I want to say, like 800 miles per hour. So he was breaking he's the one person who's broken the speed of sound without having any sort of an engine.